Hello everyone, welcome to the session. We are discussing about the kinematics in the previous class. We'll recap the small things of kinematics of previous session. We are dealing with kinematics and the types of motions. So in this we have translation and rotation and the general plane motion. So we are dealing with rectilinear, right? So this rectilinear is all the lines will be like all the way will be parallel to each other, and in these we seen a few cases like the problems will be under a linear way. That means it may be like a straight way vertically, or the straight way horizontally, or the vertically, right? So a simple example is when the car is moving linearly. So these problems comes under a rectilinear motion, and when the body is just moving freely downwards towards the gravity, and these problems also comes under rectilinear. And in the previous session we've seen rectilinear for the acceleration uniformly and acceleration variable for few cases, and we've seen small problems. And today in this session we'll see the rectilinear motion for the body which is under gravity, motion under which is gravity. See here, and these are rectilinear motions of a particle, and the two in these we have a topic like motion under gravity. Motion under gravity, that means we have a small particle which is throwing upwards, or which is coming downwards. Okay, and these two motions are linear towards the gravity, right? And for this we have a few equations of motions. We'll see that, and these are the equation of motions from which previous also we see in these equations. For equation of motion, see here, v equals to u plus gt. Here acceleration, previously we seen a here which is like acceleration, but here it is g which is acceleration due to gravity. So that's why we call this as the motion under gravity. The acceleration is due to gravity, the motion is due to gravity. And now this is the equation for velocity, and this is the equation for distance, and this is the relation between your initial final velocities, acceleration, and the distance. So in this we'll see a few formulas which are very useful to solve your problems. And now see, when your body is projected upwards, that means, see, one particle is there and this is projected upwards, and this is linear. How can you say that this one is a linear one? See, it is projected upwards. He's not mentioning anything like he's projected horizontally, or he's projected inclinedly or obliquely, something. He's saying just projected upwards. That means it is a linear towards your upward direction at maximum height. At maximum height, your velocity will be 0. That means at maximum height from the ground, your velocity is 0. Okay, and how you're going to find the maximum height the particle reach it? So this is your formula, which is like q square divided by 2g, and the time required to reach that maximum height is only to reach maximum height is u divided by g. Clear? And now when the body falls freely from certain height, it is body falls freely from certain height, your initial velocity is 0. For example, the body is starting from here. So here, in any case, the velocity always 0, and here now the starting position is this, so that's why it is initial velocity u is 0, and now it is falling freely under gravity. Now then what's your final velocity at this particular point? At this particular point when it is falling freely, and this is your equation, which is like velocity is equal to square root of 2gh. And now the time to reach the ground, see, from here to here to reach this, we require the time which is equals to v by g. That means the velocity divided by gravity. So now you can see here, it is the time to reach maximum height, it is time to reach ground, right? And next one, we have another important formula, which is like time of flight. The time required for body to reach the maximum height and to return to the point of projection. For example, if this is your point of projection, it reaches maximum height and again it reaches towards your point of projection, then the time required to travel towards your maximum height, and to return to your point of projection is the time required for this. We call it as time of flight, and the time required for this is 2u by g. And there is another special case which is like motion of a particle projected horizontally into the air. See, it is horizontal. That means, for example, you are at certain height. Okay, now from here you projected horizontally, but it will reaches to the ground again because of the gravity towards the earth, but the motion is linear horizontally, and from here to here it is the maximum range it is reached. And now at this particular position your velocity is 0 because it is particular height, right? See, this is your velocity and this is also the velocity at this particular point is 0, but when you're throwing with some velocity you have the horizontal velocity like u x. This is the horizontal velocity. Okay, and now the maximum height it reached we can calculate by like 4.905 t square. This is the time, and the next one is range. Okay, and the range is calculated like this is mu into x. Okay, this is mu x into t, and this is velocity in horizontal direction. It is not the velocity at this particular point. Okay, this is the velocity in horizontal direction, that is this velocity into the time it took. Okay, by that you are going to get this range. Clear? And here you have to remember one important point, see, take one fixed point, and from this if you are leaving your body freely towards the earth, and this is the one case, and you are throwing horizontally, and this is your second case, so when you throw again it will reach us to the ground like this, right? But the time taken to reach this ground, whether you're throwing vertically downwards or whether you're throwing horizontally, the time taken by the body to reach the ground will be the same. It is very very important to solve the problems. We'll see one small problem on this case, which is motion under gravity. See here, a body falling freely under the action of gravity passes 2 points. Here the body is falling freely. That means from certain height. We'll see the figure. From this particular height, which is like point O, from here it is falling freely, but the action of gravity passes 2 points. So it is passing these 2 points like A and B meters apart vertically in 0.2 seconds. So the given data is the meter, which is like the distance between 2 points is 10 meters, and the time it took is 0.2 seconds. From what height? That means we required this particular height, okay, above the higher point. See, from here to this point, from the above height, higher point, did it starts to fall. So from which point it starts to fall, that we require. So that means we require this particular x, but we have this distance between A and B, and we have the time how it reached between these 2 points. Okay, we'll see here. We know that here the distance, this is the equation of your motion for the displacement, which is like x. This is x we required, equals to ut plus half gt square. Here you are using the acceleration due to gravity, and that equals to, what is your initial velocity at this particular point? 0, right? And plus half, this is your acceleration due to gravity, and the time t square. And if you simplify this, you are going to get 4.9 t square. And now the distance traveled of OB from here to here, it is like x plus 10 meters. The time taken is the t plus 0.2 seconds. So 0.2 seconds is for distance traveled between A and B, and the t is for the distance traveled between O and A. And now by your displacement equation of motion, x plus 10 is equals to ut plus half gt square, that equals to initial velocity is 0, acceleration is this, and this is your time to reach the point B. And now if you simplify this, you're going to get this equation, which is like 2, and this is your first equation. And if you substitute, or if you simplify these two equations, what you're going to get is time, that is t equals to 5 seconds. Just simplify these two equations, you're going to get time 5 seconds. Substituting values of t in equation 1 is your x equals to 4.9 t square, and that t, which is like from 1, so you're going to get the x value, which is 122.5 meters. Clear? Thank you.